Hello, my dear students. Welcome to our physics lesson. It's Darasa Online. And today's discussion will talk about the polarization of waves. This is the subtopic in the vibrations and waves. And if you remember, in your previous discussion, we talked about the method of producing polarized lights, which were 1, by polarids, 2nd, by reflection, 3rd, by double refraction, and the 4th, by scattering. And in our first discussion on the polarization of waves, we talked about the two methods, that is by polarids and by reflection. And we saw that in summary of what we will discuss about that, we had the incident ray, which is now falling. That is the normal. And this is the surface of the plane. That's the incident ray, which is an polarized light. And we saw that this is the angle of incidence there. And this is the angle of reflected rays here. And again, we had the refracted rays. And we saw that when the reflected beam is completely polarized, this the angle here is 90. And we saw that from here, if it's coming from the first medium, the second medium, we found that this is N1, sine of the angle of incidence, equals to N2, sine of the angle of refraction. We come up with the formula that if you find the ratio, that means N1 sine R I equals to N2 sine R. That means this is equation number 1. And we remember we said if this is 90, we had I plus R. It's giving us 90. If you make R the subject, our R equals to 90 minus I. And we found that it is N1 sine I equals to N2 sine 90 minus I, which gives us, this is the cosine of the same angle, N1 sine I. We have, this is sine I over cos I. This equals to N2 over N1. So we come up with this formula. It was given at the name Bristol's law. If N1 is the medium, which is involving air, so N1 equals to 1. But depending the nature of the first medium. And we come up with the formula for tan. So this is the tan of the angle. That is the angle of incidence, which is given the name polarizing angle, which is N2 over N1. Knowing the angle of incidence, which makes the reflected and reflected to be at 90 angles, which means produce the polarized light, you can be able to find the refractive index of the second medium. That's what we discussed in the first part of polarization. Not only that, but we saw that when you have, we're using polaroid, that means we had, this is the first polaroid here. And this is the axis of transmission. And this is our unpolarized light, whose intensity is known. And it's allowed to pass here so that it goes to the second polaroid, whose axes are parallel. And we saw that, what is the effect? It means one of the intensity, one of the component of the unpolarized light will be reduced. So it remains with the I naught over 2. We saw that which component will be absorbed? The component which is perpendicular to the axis of transmission will be absorbed. So it remains with this. And since this axis, this is parallel to the transmission axis, also this component won't be affected. It will be the same I naught over 2. But we saw that this is case 1. If it happens, we had the same unpolarized light falling on this to the first polaroid, which is given this axis is vertical. When this second polaroid is rotated until the two axes here, they are at right angles here. when the two axes at right angles make, we say these are crossed parallel. So this will be half of 2. So the observation here, when you observe here, you can see that. When you observe the intensity of the light from this now, the second part, which is at right angles, the first one, we saw that the intensity of light decreases to 0. To 0. Here it is I naught. It is half. You can see what is happening. When the angle increases, the angle here is 0 between the two, when they are parallel. When the angle now will change, will rotate the second part, it means the angle is measured from the vertical until the angle is 90. So that's the intensity of light decreases from I naught over 2 up to 0. Now the question was, what is the effect of this second rod if it's not parallel or it's not perpendicular, if it makes an angle, certain angle, which is the acute angle between the two? So our today's discussion, we see what happens when you have these two parallels here. This is unpolarized light here. We have two components, and this is passing through the first one. But the second parallel, it makes an angle here. That angle is not 0, it's not 90. It's an acute angle here. Maybe 30, 20. That angle here is given as theta. How do you find the intensity of light? This is I1, which is an absorbed. We know it is given by I naught over 2. How much will be observed here? How much? That's the question. How do you find the intensity of the light which will be allowed to pass through the second part when this angle is not 0 or 90? That's our today's discussion. So very interesting. To see that, we have the theorem. This is given Mara's theorem, law. The theorem says that this I equals to I naught cosine squared of the angle. Let's see. This is the theorem which is used to find the intensity of the light when the angle here is given. Generally, you can talk about even here. What does this law says? The law says that if you have two parallels here, that is the first parallel, this is unpolarized light, whose intensity is I naught. And now from here, let's take this is our I1, the light which is transmitted from this I1. And then here, let's take here, it is, our previous discussion was this, parallel. What happens? I'm getting the same answers. This is I3. So Barras is talking about the angle, this angle in between the light from here, the second. He's talking about the intensity of the light emitted to the second, through the second parallel from the first in between. So starting from here, you should know how much of the intensity of light is here. For example, here, we know this is half. What happens when it's passing through the second parallel, which is parallel? It means the angle here is 0. So our angle between the two axes is 0. This is 0. So what is the I3? I3 equals to I1. This is talking about the I naught, not I naught here. So initial is, when coming to here, we'll consider what was the initial intensity of the light coming from this one before passing to the second parallel. It's I1. And then cosine of the angle squared. This, our I1 is I naught over 2. Cosine squared of 0. We know cos of 0 is 1. So get the same answer here, I naught over 2. This is the result that we saw in the previous discussion. When the angle is given, that's how you can find the intensity of light passing through the second medium parallel or the third one, using this theorem. Now, what happened when the second parallel is at a right angle? If it's at right angle, let's prove what happened if this was our I naught, now the two parallels are at right angle. The angle here is 90. How much will be observed here? How much? We saw that this side amount here will be equals to I naught over 2, because this axis, the component which has been observed here is vertical. This vertical component is part of the transmission axis. The same amount will be allowed because it's parallel. Now here, the angle is 90, so using the formulas, this is, let's take this is I1. We know this is I naught over 2. One of the components has been observed. How much will be observed, transmitted here? This is I3. So I3, this equals to what? To our I1. Cosine squared of the angle, which is 90. So our I1 here is I naught over 2. Cosine of 90 is 0. So that gives 0. Very wonderful. You can see now, you can use this theorem to find the intensity of the light emitted, transmitted through different power rates at any given angles. So that's how Mara's theorem is applied for these cases. Now let's see example number 1. This is not example 1, but this is a continuation of our previous discussion. This is example number 3. Example number 3 is talking about start number 1. In our previous discussion, we had 2 examples. Number 3 is talking about we have unpolarized light. Unpolarized light, we normally use the symbol for unpolarized light is this one. Intensity is given as I, yes. Passes through 3 successive parallels. There are 3. How are they arranged? Maybe this is the first parallel. This axis here. If the second parallel is rotated at 45 degrees relative to the first one, okay? So the first here, this is the first parallel, it's vertical, but the second one, the axis is at 45. 45 relative to this. So this angle here is 45. And the third parallel has its axis being rotated 90 degrees to the first. So the angle between the third one and the first is 90. Means the third one is horizontal here. So the angle here is 90. From this angle to the first one means here the angle is 45. We know vertical, horizontal makes a 90 degrees. Let's take this is I1, this is I2, this is I3, where you can find this is the final intensity of light which can be observed by someone who is observing through a device which is used to detect the intensity of light after passing through the first parallel, second parallel, and the third. Now the question is asking about what is the final intensity of the light after this process. Process means it passed from, we had unpolarized light whose intensity is given as I. It passes through the second parallel, so we can find how much has been transmitted, and we know here automatically we have this I1. According to our observation in the previous lessons, we have seen that this component which is parallel will be allowed to pass, and this one will be absorbed. So the remaining half, it is half of the original intensity. We use it I. So depending on the question, you're given I, not I naught. Then how much will be, how much of this I over 2, which has been allowed to pass, will be allowed to pass through the second parallel. The angle now between is 45. That's where you're supposed to apply Mara's theorem. So the formula says I2 equals to the I1. We don't go back to the origin. So you're starting from here, I1 to I2. passes through the second period is given by the cosine of the angle squared there. That's the theorem. But I2 is what we are looking for. How much is this? How much is that? The angle between is 45, theta. We are given that theta is 45. So we find that I2 equals to I1 cosine of 45 degrees squared. That's I2 equals to I1. I think you know, you can use your arithmetic, even without using calculator. Cos of 45 is known, is radical 2. Radical 2 over 2. Because you're looking for the fractions, so better you convert that one without the calculator. So this is radical 2 over 2. This is a cosine of 45. If we square that, it gives us I1. That means it's 2 over 4. And we know I1. I1 is I0. So it's I over 2. Bracket times 2 over 4. These 2 and 2 we cancel out. So we have I over 4. That is the intensity of the light that will be transmitted through the second period. It's very interesting. You're supposed to go systematically, and you can see when the angle is known, just a matter of plugging here. The cosine of 45 is radical 2 over 2. If you square in mathematics, you have this is 2 times radical 2 over 2. And when you multiply this, this will be 2 over 4, which is a half. So a half, and that a half will give us a quarter. So we know how much of the intensity of the original, that means of the second to the second period, will be transmitted compared to the original intensity of the unpolarized light. And as I said before, this can be given I0, can be given any symbols you normally use to present that intensity. Now let's find the I3, the final. The question is asking, what will be the final intensity of light after this process? It means after passing through the first, second, and the third period. What will be the final? So we are going to check I3. What is I3? According to the formula, it's I2 cosine squared of the angle between the two periods. And here again, you can see the angle between the second and the third period is 45. Our theta here is 45 degrees. And you can find that I3, this equals to I2 cos of 45, cos squared of 45, which is the same as I2 bracket radical 2 over 2. We saw this again equals to, we saw this is a half. If you square that. Now what is I2? We got this is I over 4 times a half. This gives us I over 8. Very interesting. You had seen now that when the angle increases, you can see even the intensity of light changes. So the final intensity of the light which will be transmitted after all this process will be I over 8. It was I. After passing through several periods, the intensity of light changes to I over 8. I think you have enjoyed. I think now you are making a follow-up on that. It's very easy to see and to make use of this theory. An idea that you should know, you're looking for the angle. The angle, that angle should be the angle between the periods. The angle from the first to second, third to fourth, fourth to fourth, and so on. So the angle should be between the two periods. That's the end of part A. Part B, say now, if the second period is removed, let's draw our original diagram before. See what this part B is talking about. This is A, B. In the first arrangement, we had I as an polarized light, and we had the first period here, which is vertical. And then the second period was at 45. Here, 45. And the third one, it is at 90 with the first, so it means this angle here is 45, and this one is 45 again, 45 here. Those are at transmission axis. This is the first one, this is the second, this is the third, B. But B, if the second polaroid, this one, is removed without disturbing others, it means you remove that, what do we make? What do you see from there? If you remove the second one, we have now the first polaroids will remain here as it is, and the second polaroid here, it's not there, so remain with the third, which is now horizontal like that. Yes, and our unpolarized light intensity is I. What will be the final intensity? It's very easy. Here, you're looking for the intensity, light which will be produced when passing through the first and the third. So this will be I over 2, we know. One component, this will be absorbed. And here, then from here now to the second polaroid, which is now given as the third, which remains after removing the other polaroid. So how much will be observed here? The angle here is 90. The angle between them is 90, we know. This is I3 equals I2 cos squared of the angle, which gives us I2 here is I over 2 cos squared of that angle, 90. This gives us I of 2, cos of 90 is 0. That means the final intensity will be 0. And this is the case we discussed in the first part, that when the two polaroids are at right angles, the intensity of light produced will be 0. And we have proved from this formula here that when the angle between the two polaroids is 90, at right angles, so the intensity of light will decrease from I over 2 to 0. So the final intensity will be 0. That's example number 3. Now let's turn our attention to the example number 4. Example number 4, we have the unpolarized light. Again, falls on two polarizers. Polarizer sheets whose axes are at right angle. The information says that we have two polarizers. The names are changing. And this axis here is, for the first. Since it's an polarized light, which is falling on the two, it should be in the form of vertical and horizontal vibration like that. And this is now, you may use I naught. And the two axes are at right angle here. This is 90. What fraction of the intensity, the incident light intensity, is transmitted? It's very easy. We have seen here, from the third example, this will be I1, maybe. This will be I2. This will be a half of that. And this will be how much? Because the angle here is 0. So you use that formula. Again, we saw that this will be 0. It is 0. This is part A. Part B is what fraction is transmitted if a third polarizer is placed between the two. So this is the intensity here is 0 because the angle between them is 90. So you are giving now another condition that the same arrangement we had the first and the second here. And now we have the third polarizer has been introduced between the two, so that it makes 30 degrees with the second. So this is the angle somewhere. This is the axis. of the third one, which makes 30 degrees with the second. Here, that angle here is 30 degrees. So our third parallel is here. That angle is 30 degrees. So our original and polarized light has intensity of I naught. So you should know how to draw these diagrams. Since the first two axes were at right angles, so the angle between the two axes is 90. And we introduce another parallel in between them so that to make an angle 30 with the second here. Then, since this is 90, that angle between the first and the third means the one which has been introduced in between is 60. So you're looking for the fraction of the transmitted light through the last one here. So let's take, this is I1, this is I2, this is I3. From this diagram, you can see that I1, we saw from our previous discussion that I1 is not using, you don't use formula, but you use the concept that when you have two unpolarized lights, when you have a polarized light passing through the first parallel, so the component which will be allowed to pass is the one which is parallel to the axis, and the one component will be absorbed is the horizontal component, which is at right angles. So I1 equals to I naught over 2. We are sure of that, so according to our previous theory. Now, we know I1 is I naught over 2. When you're looking for the intensity of the light which will be transmitted to the second parallel, which is given as now it was the third, now it has been introduced in the middle. So since we are looking at the angle, the angle between the two parallels should be known. According to Mara's theorem, when you're talking of the intensity of the light transmitted involving two parallels, the angle between them should be known. So the angle between these two is 60. Here is 60. That's where you apply Mara's here. This area here, but here you don't apply. We use the concept that as long as this is first parallel, so half of the component of the original and polarized light will be absorbed. So from there you can find what happens in between when you have the second parallel here. You apply the angle, this angle 60 to the Mara's theorem, so that you can find I2. So from our theory, from I equals to I naught cos squared theta, that I naught is not the original one. It depending where this light is coming from. So from this now, we can find that I2 equals to, referring to this, it is our initial, which is I1 cos squared of the angle between these two parallels is 60. Comfortably know what is initial. The initial here, don't confuse with the initial which has been taken from here. So sometimes you can use the maximum. Maximum. And here for the maximum here, we're referring the light intensity which has been produced before coming here. So it is the I1. So we have I2 equals to I1, which is I naught over 2. We got from this equation number 1. Cos of 60, cosine of 60, and then you square it. I think you can use your calculator to check that cos of 60. Even if you don't use that, you know that how much is that? The cos of 60 is 0.5. So this is a half. I naught bracket 0.5 squared, which is a half. So we take this will be I naught over 2. If you square that, you get 1 over 4. The answer is I naught over 4. That is the, over 8. So from there you can see how much will be produced in the second, from the second parallel here. From this one is get I2 equals I naught over 3. What will be the final now? What will be the final intensity from this, the middle, to the last one here? So you can use the same formula here, this formula, but the angle there is 30 degrees, and we have I3. I3 equals to maximum of cos squared theta. And you know this angle here is given 30 degrees, and our I2 is I naught over 8. Correct. So this is I3 equals to I naught over 8 brackets multiplied by the cosine of that angle in between, cos of 30 degrees, and then you square that. Cos of that of 30 degrees, using your calculator, you can find how much is that. Cos of 30 equals to 0.8. You convert into fraction, you get, if you convert into fraction, 0 cos of 30, if you square that value, you get 0.75. I3 equals to I naught 8 of 8, and 8 of this is 0.75. Mathematically, we know 0.75 equals to how much? It's I naught over 8. This is 3 over 4. Check 3 over 4 is the same as 0. You convert in your calculator, you get 0.75. You convert this decimal into fraction, you have that 3 over 4. Then the final intensity will be, this is 3 I naught over 32. 3 I naught over 32, because there is no way you can simplify that. So that's how you can find the intensity of light using this. Now we have seen example number 4. That was very interesting here to see how do you apply this law when solving the equations involving the intensity of light passing through different polarities at different angles. Now, I think you have making a follow-up on our discussion. We have seen from the first part of our presentation on the polarization and how we can solve different questions involving these subtopics. Now, let's see now if you can attempt this question as the part of your assignment. Now, you have seen those examples. Let's see the assignments that you can do wherever you are, and test whether you have understood this part of polarization. The question is asking now, A, at what angle should the axis of the two polarities be placed so as to produce the intensity of the incident and polarized light to be 1/3 of original value? At what angle? If remember, in your previous discussion, we had been finding the intensity of the unpolarized light after passing through several polarities where the angle was given. But this time, the angle is not given. We are looking at what angle we should make these two polarities, which are supposed to be either oriented, we don't know how, so that the intensity we know from our discussion decreases when the angle increases, when it rotates, until when it's 0, when the two axes are at right angles. So how? How do you find that angle? Step number 1, you draw the diagrams. For the, let's consider the first polarity is at this point here, this or maybe at the left side of your board, and then assume this is an polarized light whose intensity is I, because the question is talking about the light which is falling on this one is unpolarized. It means it has this vertical and horizontal components. And we know that this cannot be horizontal. If it's horizontal, the two axes will be at right angles, and the intensity will be 0. It means there must be an angle somewhere here. Let's choose the axis here of the second period to be here. This is the second period. This second period is here. That angle here is not given. This is our first. This is our second. So that this will be I1. This will be I2. How much of this angle should be made? How much should be this angle so that the intensity of the light produced here to be 1/3 of the original values. Of the original value means I0. It reduces, because it is I0, it reduces 2. It reduces 2. And to be reduced to its original values, half of that, 1/3 of that I0. So we can find I1, because we know I1 is half of the I0, and the component that will be absorbed is this. So remain with I1 equals to that. Now from here to that side here, we can see that we can find how much is this, which is given. So let's take this I2. This is from the formula, maximum cosine squared of the angle between. From here, from this Malus theorem, we are taking now, we are looking for I2, which is passing after being transmitted through the second period. It's given by I1 cos squared theta. There. I said this angle should be applied between the two periods. Now we have I2. It's 1/3. Over 3 I0. Do you have I1? Yes, I1 is half. Half of I0. The cosine squared of the angle is not given. That's our starting point. To find the angle, you should know that. And this one is given. I2 is given, which is 1/3 of that. Now, what will be the angle here? So I0 we cancel out. And if you make this cosine of this angle, the subject, cosine squared, this equals to 2/3 from there. But I make some sort of multiplying by 2. If you multiply by 2 on both sides, these two will cancel out, and this will be 2/3. So from there, to find the angle, first, you should find the cosine of that. You'll find the cosine of that. Cosine of this angle, when you have this x squared equals to 9, how do you find x? X is taken as the square root of 9. So to get x now, here our x, you can see, it looks like cos. Sometimes the cosine squared in mathematics is written as the cosine of that angle squared. So let's find the square root of that 2/3. 2/3 give us 0.6. 0.66. In other words, cos of the angle theta is 0.66. And from there you can find now, because it's repeating, you don't write 0.67 approximation. This approximation will lead to the wrong answer. So you can use the same calculator, automatically find the cos inverse now. 0.816. And then cos inverse of 0.816. How much is that? So you make sure the calculator is supposed to be in the proper mode. So cos inverse, it is 35. Good. 35 degrees. Approximation that it is 35.26. So you can see now, if the angle between the periods is 35, that means the intensity of the light reduces to I0/3. So that's how you should approach this question where this angle is not given, but we have other information. So you can be able to find the angle in between the two parallels so that you can produce that intensity which is produced at the end. Part B, we have this another part B, different assignment, and you can see now different approach of the question that will be given. Two parallels are arranged. We have two parallels which are arranged. How are they arranged? The two parallels are arranged such that the axis, transmission axes are parallel. Okay, this way. Now, make sure that you are making a follow-up on this, because this is the assignment you're supposed to be doing at home while making a follow-up here. So these are the two parallels. Let's go together. You draw the line here. The axis, transmission axes are parallel. The first one, the second, according to the question. The two parallels arranged so that the axes are parallel. We talk of the axis. We talk of the transmission. This is the transmission axis. Now, the third parallel is placed after the second. Okay, the third one is after this. How is it now placed? It makes 60 degrees with it. So you have another parallel here, which is now making an angle of 60 degrees with this one, second. So the arrangement of the parallels is very important because you may end up with the wrong answers. So you should know that the arrangement of the parallels is proper according to the question which is given. So the second parallel is placed after the, so the third one is placed after the second here, not in between. It should be after this, because this was the first, second, and then thereafter. How? It makes 60 degrees with that. Okay, horizontal here, we have this angle is 30 degrees, which makes 90. So our aim here is this angle here. Find the final intensity of the light transmitted. So we had our original polarized light here. Let's assume it's polarized light. And then we have I1 here. We have I2 here. And then we have I3. That's where you can observe. You can observe the intensity of the final after passing through these different parallels. Okay, let's find I1. I1 is very simple because we know this will be absorbed. It's a half I2. And then I2. What's I2? You can use the formula which said now it's I maximum cos squared, or we know this is be the same arrangement here because this is what should be absorbed here is one of the components, and this is parallel, also parallel. It will be the same as half of 2, but you can check. The angle between them is 0, because they are parallel. Cos of 0 equals to 1, so this will be maximum is I0 times cos of 0 is 1, 1 squared is 1, giving us I2 equals to I0 over 2 again. But you have seen the angle between them is 0. You can use that theorem, or you know the concept here, because this axis, they are parallel. The component will be, which will be allowed to pass, is the same, and there are no changes here. Now our I3, that's where you can have changes now. It will be I maximum, which is I2 cosine squared of the angle between the two axes, which be I2 cosine of the angle between them is 60 squared. We know I2 is given from here. It's I0 over 2. And our cos squared, cos 60 is a half. Check your calculator. Squared. This will be I0. That one's 1 over 4. And the final answer here, I3 equals to I0 over 8. That's the final answer. But the very important point here is the way the arrangement should be made, depending on the question. So if you make a mistake, the first one is here. The second probably is here. So if you introduce the third in between. If you don't read the question properly, you may introduce here in between the two. So this will be 60. But how much is that? It's very, very difficult to know what's the angle. But the question says the third was introduced after the second, so that it makes an angle 60 with it. So from there, that's where you can apply correctly the formula to come up with the final solution, I0 over 8. Now, part C, now you are now in the position of giving now the difference between sound and light waves. And the question says differentiate between the two. You're supposed to give 4 points. The difference, basing from our discussion. So from our first part of our polarization, we saw that when you talk of polarization, you're talking of polarization of transverse waves. Polarization of the waves whose vibration can be restricted. And we saw that there's no way you can restrict sound waves, because these sound waves are longitudinal waves. For the first difference you can give is maybe, to start, you can explain how these waves are, nature of these waves. Maybe these are transverse waves. Here, this is a longitudinal waves. We know how they, if you're making a follow-up on the first discussion, the first part of this polarization, you can have this idea that light and sound wave can be differentiated in this way. This is the transverse, the other one is the longitudinal waves. The second, that the vibrations, the definition of the transverse, vibrations of the waves, how are they? Are perpendicular to the vibrations, to the directions of propagation of the wave itself. Of course, remember we said this is they normally move like this. It has two components which are at right angles. So the way the particles are moving, they are making 90 degrees with the way the waves propagate. But here, these are the vibrations of the particles. Vibrations of the particles, not the waves. The particles within the medium. The vibration of the particles are along the same direction with the propagation of the waves. I'm giving this point so that you cannot miss this question. It's very difficult to see here, but when you are told to give 4 difference, sometimes you may give those points which are not basic. So that's the point number 2. You base on the definition of the transverse waves, and then you base on the definitions of the longitudinal waves. It depends. You can give even 6 points here, depending on the nature of the question or the way the question has been given. So number 3. Now, number 3, we can talk about these transverse light waves can be polarized. Can be polarized. That's why we saw from our discussion. This cannot be polarized. This cannot be polarized. Yes. Then the speed of the light waves is not depending on the medium. It's constant. The speed of light wave does not depend on the medium. Is constant. The speed of light is given by c equals 3 times 10 power 8. Is greater. This one is greater than the speed of sound. The speed of sound depends on the medium in which the waves propagate. For example, when we talk of speed of sound, when these waves are produced in air, when you produce sound in air, it's different when you produce sound in water, in the medium. So, for example, in air, at normal temperature, V equal 340 or 330. It depends now. When you have, this is the speed of sound in air. Now, this speed, the speed of sound, depends on the medium in which it propagates. I think you have enjoyed our programs, and it was a very nice program because we have been talking about the concept that applies to our life. And we mentioned here, if you remember, this part of polarization is applied in our life. And I mentioned some areas where it can be observed. And if you remember, we said this concept of polarization, not only polarization, the concept of light itself, applied in medicine, engineering, and in the police, they normally use this for detecting the speed of the cars when they're coming. And this concept of polarization, particularly, it's applied in making or designing the board of the plane. If you remember, when you are in the plane, inside, it's very comfortable because the intensity of the light has been reduced. That's one of the factors they normally consider when designing that. And we say this concept of polarization is applied also when those who are producing music, observing objects of movies in 3 dimensions. It's easier to see an object in 1 dimension, but it's not comfortable when you see objects in all angles. I know most of you know we are happy and you're enjoying when you're observing the football matches. Sometimes you can see the goals are scored at different angles. Now, what is that? That is the use of polarized light. So, this concept of polarized light is usually where different cameras are taking picture from different angles. So they apply polarized light is at a vertical or at a horizontal. At the end, they're going to combine the two so that your eyes now, your right eyes will be able to see through the other side, the camera which is on the left. And the left eyes will be able to see the image of the camera produced from the right. So from that angle, you can be able to see the whole image of that object. Very interesting. That's how makes this concept of polarization be interesting in our life. Those are a few aspects where we can see application of it. But if you like, stay tuned to our programs. More programs are coming. More topics are coming, particularly in physics. And thank you for watching.